Hello, this is Roger Kochbar for the Bioelectricity course. This is week 8, and we're in segment number 8, where we look again at stimulation of a cylindrical fiber with cuff electrodes. We're going to get to a complicated but fascinating result during this lecture. So just reviewing where we were, we said if we have a cuff electrode, here it is, then a stimulus current applied to this electrode will result in the change in the transmembrane potential. And the change in transmembrane potential, after a while, will be given by this result. This is the steady state result, meaning the voltages that result after a long enough time that they've all reached their final values. So it's fair of you to say now, well, how long does this take? What are we talking about? We're talking about a microsecond, or a millisecond, a second, a lifetime? How long is it that it's going to take to get to these voltages? Because after all, that's very important to us. Well, I have good news. The good news is this problem has been solved. You can look it up. Not only the solution, but the derivation of the solution in the bioelectricity textbook, but here I will just show it to you. And here it is. It's what I call the Tiger function. Now, as this note says, right there, I call it the Tiger function because I want to have a name for it. But I don't think anybody else uses this name because it's been a secret. But now I've told you, and you're my friend, so you can call it that too if you want to. In any event, it's a fairly complicated function. It has a positive part and a negative part. It has time, and it has constants based on time, such as tau. So tau is the time constant of the membrane of the cylinder. It includes the space constant, which we saw before, which are the combination of the spatial characteristics of the membrane, and it includes the stimulus current here. This is one of those solutions that you get to where you're a little sorry that you asked the question, because the answer came out to be perhaps a bigger mouthful than you were hoping for. But let's look at it a little more since we have it. It is useful. First of all, in the equation, this function ERF is called the error function. That's an abbreviation for error function. It's a function that's a tabulated function in the same way as sine and cosine. If you have the right mathematical package on your computer, you can just pull the number values of ERF right out of that mathematical package. Here is the definition of ERF, and as you can see, it seems to be an equation that is most likely related to normal distributions and probability, because it's this integral of e to the minus x squared. It's kind of amazing that it shows up here in the solution of potentials in a cylinder. But there it is. However, that's not our primary interest. We started off here asking, how long does it take to have an effect if we apply current to a cuff electrode at x equals 0 in this cylinder? So we've applied minus I0, and we want to know what sort of an effect are we going to see. So what will happen is we'll see potentials that'll look like this. First they'll look like this, and then they'll look like this, and then they'll look like this, and then they'll look like this, and this is about 80% as large as they will ever be And this height is achieved in one time constant. So that height is achieved at t equals tau, and that is the same as t equals the membrane resistance times the membrane capacitance, and that is for membranes something in the order of a millisecond. Now, it could be less, it could be more. It depends, of course, on the exact characteristics of the membrane, Rm and Cm. So saying a millisecond is just an order of magnitude result. But it gives you an idea. It takes about a millisecond for us to get most of the way there, about 80%. And then we can have 2 or 10 or a million milliseconds, and it will get closer to the largest value. The largest value will look the same. It'll be the same curve, just up a little bit higher. There is, however, a subtlety to these curves that's worth noticing. As time goes by, it is the case that more and more and more and more membrane is being affected. So there is a spread with time as well as an increase in magnitude at the center. On the other hand, as we were saying in the previous slide, even if you wait forever, it only goes so far. Well, you could say, well, it is affected a little bit in the sense of exponentials, no matter how far you go. Yes, I know, but if you think about it in terms of physiology or engineering, once you get down to about the 1% level, it really doesn't matter anymore. Well, that was a different result and requires a different color. Thank you for watching this segment. We'll see you shortly in the next one.